Hey guys, my name is Simon Fiedler and today I want to record another very exciting Houdini tutorial. I think it's kind of dedicated to Cinema 4D people who want to extend their toolset a little bit and maybe use Houdini for very specific tasks and use that one then also in Houdini, but also for people who just want to learn how to use this piece of software, which can be pretty complicated in the beginning. And some while ago I posted this video here, which is called Creating Houdini Digital Assets for Cinema 4D. And I built this setup here originally for the seed project at Xponsa, but sadly it didn't make it into the final film, so I now have this scene file here and thought then I can also share it. And in this video I showed how to turn the Houdini setup into a digital asset that you can use it in Cinema 4D. But I actually didn't show how to create the setup in Houdini from scratch, and this is what I want to show today. It's not really an introduction to Houdini, but I'll try to explain everything as clear as possible, and I hope you like it. Just one little disclaimer, which I want to make clear. I'm also learning Houdini at the moment, so it might be possible that not everything what I show you here is 100% correct. So if there's something which I explain the wrong way or when I make mistakes, please write it in the comments that the people who watch the video know what I'm doing wrong, and I'll try to make it better the next time. So yeah, that's it for now. So let's jump in here and build that setup. So if you open up Houdini, it should look like this, pretty empty scene. And one of the hardest things for me when I started to learn Houdini was to understand the context. I think this is the main problem for all beginners. And I don't think that I can cover the whole concept here in this video, but I will try to explain it on the way when we build our stuff. So basically, if you're coming from Cinema 4D, it's kind of similar to what you know from your package. So you have the viewport here. Of course, this whole layout can look totally different. I think if you fire it up for the first time, it looks a little bit different. The scene view is down here, and on top of that is the parameters, but I like it more that way. And of course, I have to rearrange it a little bit because my screen recording space is a little bit limited. Yeah, but we'll see, that's basically it. And you see here in the top right corner, we see scene. So this is basically our object manager. So in here you can see all the objects which are existent in your scene. And the parameters view here is basically the attribute manager that you have in Cinema 4D, where you adjust all your values and stuff. So when we start off, I need to create some geometry. So in this case, I want to use a simple sphere. We can exchange that later, which starts to boil and deforms, and we get some bubbles on the surface. So for that, I will create an empty geometry node. So you get this search field if you type tab, and then you can type in stuff here. And for this one, I simply type in geo, and you get the geometry. And this is like an empty placeholder. So for example, if you create a sphere, you can see that those nodes look exactly the same. If I click on that one, it says geometry, and on the sphere it also says geometry. But this container is empty, and in this geometry, if you dive into the sphere, you see inside of this geometry, we are now on geometry level, you have the actual sphere geometry. So if I jump back, delete the sphere again, we have an empty geometry node, and we call this one geoboil. So this is our boiling setup. So let's jump in here, and in there is one node called file. You use that if you want to import an OBJ or something like that, so we can delete that. We're now in our node geoboil, and this is totally empty. And we start off with a sphere. So type tab again and write on sphere, and here we go. I will just disable the grid here. It's the top button here. And now you have your sphere. And by default, if you take a look at the sphere node, it's set to primitive. So this is actually, if you're in Cinema 4D and create a sphere, is also a parametric object where you can change the values. And if you want to do stuff with the polygons in C4D, you convert it to a polygon object. In here it's a little bit different. You simply set the primitive type to polygons. And then you can adjust the frequency down here. You can also set it to polygon mesh, then it looks like you know it from C4D with rows and columns. In our case, we will we will use primitive type polygon and adjust the frequency to something like this, maybe 10. So this is our geometry, which should start to boil. And to make it boil, we need to create some bubbles. And for that, we will use a very simple particle system. There's also different ways of using particles in Houdini. I show one way which is possible. If you open Houdini and start playing around, you will end up using those shelf tools up here, which are nice. It's kind of like presets in Houdini, so you can simply say, okay, I want to emit particles here, press source particles, and then a whole node structure is generated for you. This is cool to find out how stuff works and to see what's possible. And later, if you understood everything, it's also good to save some time. But if you're in the process of learning the software, I would highly recommend to at least try to build the setups by yourself and connect all nodes by yourself. Then you know exactly what they do, and after that you can use the shelf tools to save time and connect them in a different way that you need. So for now, we start off with the pop network. Just type in pop, and then you get this one. And now this is our first contact with a different context. So I simply connect my sphere to the first input here and set the display flag, which is the one on the right, to the popnet. So this actually defines what you see in your viewport. Set to here, and then we already see some particles, and if we hit play, we see them, the particles generating on the surface. And you can see that it runs pretty fast in your timeline, which is because Houdini caches the current simulation. You can see it because the timeline is blue. And then it runs as fast as possible. If you want it to see in real time, so with the frame rate that you set in your project, you simply hit this real time button over here. And then the simulation is slowed down to real time, which is pretty funny because in most other softwares you are kind of happy if it runs in real time at all. But Houdini is actually so fast that sometimes you have to slow it down to real time. Okay, contexts. I'll try to. I'm not so well prepared again, so it's kind of a freestyle session here. But I'll try to explain everything as good as I can. So right now we are on the geometry context, and in there we will find all the SOPs, which are surface operators. So every time you model something or you deform objects, or move points around, you do that in SOPs, so on geometry level. And if we double click on the popnet, we'll dive in, and now we're in dynamics, which are the DOPs, dynamic operators. And so POPs are actually DOPs. I think only in earlier versions of Houdini there was a POP context for particle operations, and now all the particle stuff is merged with the dynamic stuff, that it's one environment. And now everything lives in DOPs, dynamic operations. You can imagine all those different contexts, maybe like if you have a big visual effects company and you have several divisions, so one division for the simulations, one for the character stuff, one for the modeling. So it's like in a big factory where you have different divisions with different specialties. And if you have some kind of geometry and you want to create particles, you give this geometry to the division which takes care of particles. They do their calculations and they give you back the points that they calculated. Excuse me, I need to grab a cup of coffee. Okay, so right now we are in our particle network, and by default Houdini provides us with this tiny node graph, and this one node over here we can get rid of directly, because if I zoom in and click this one, you see it's a merge node, which means that if I have several particle sources I can merge them together. But in our case we don't need that, we only have one source, so we just delete it. And and now our node tree is a little bit smaller and easier to understand maybe. So I'll try to understand that now But first thing, what I want to do is to make those points a little bit bigger. So if I go back here into the on geometry level. By the way, if you dive into a network and you want to go back, you can hit the U button on your keyboard, and that brings you back. And now we can see the particles that we generated, but they are pretty small. I don't know how good you can see it. So we can make that bigger. Just go with your mouse over your viewport, hit D on your keyboard, and go to the geometry tab. And here we have point size, and you can simply increase that. It doesn't change any geometry, it's just the way they're displayed, and I like to make them bigger just for the recording, but you can see them better. Excuse me. So let's go back into the PopNet, and I'll try to explain what happens here. So in the middle we see our pop solver. So the pop solver is actually you can see the icon is a little brain. This is actually where all the calculations take place. And up here we have two objects. One is the pop object and one is the source, the pop source. So this one actually generates your particles, and this one stores your particles. So you generate particles, they are stored into this object, and then forces and stuff come into play. And usually, for example, if you're in subs in Houdini, you calculate the stuff from top to bottom, so one node to the next. And in the particle solver, it works from left to right. I hope I explained that in the right way. Manuel from Xpons explained that to me, so I hope everything is correct how I say it. So basically, you generate points here, the points are stored into the pop object, and then it goes to the next step. Forces and stuff come into play, they get solved, and on the end of the frame, the particles are again, the result of the particle simulation are again stored into the pop object, and you go to the next frame. So it goes like this, over and over again. So in our case, the particle setup will be pretty simple, because we just need particles which grow on the surface and die down after a while. So if I hit play right now, they just get born and they don't die, so we have to adjust the lifetime of the particle. And all the stuff like particle speed, the initial speed, and lifetime, you adjust in here into this pop source object. So click that, and then we go to the birth tab. And first of all, I want to adjust the birth rate, because this is way too much. So set it down to 50. We press play again, and we see this is a nice amount of bubbles. And we have the life expectancy. This is measured in seconds. So if we set that, for example, to 1.5, want to play, then we should see that the particles are generated, and after 1.5 seconds they die down again. And I also want to have some variation there, that not all of them live exactly 1.5 seconds. So in life variance we can type in something like maybe 0.8. I think that looks good. Okay, perfect. Then we hit U to come back. And if we here press play, we only see the particles which are generated, which is pretty cool. So this is actually step one. Let's push it over here. And now let's take care of a few things. First of all, we don't need points here, we need bubbles. So we actually need also some spheres which have a specific size. And this is super easy, because we can simply clone a sphere onto those points, to speak in Cinema 4D terms. And first of all, we need another sphere. Create that here, put the display flag on that one, that we can see it. And I will also set it to polygons. Increase the resolution a little bit and make them smaller, maybe 0.25. That looks good. So those are now our points, and this is my sphere, and I want to clone this sphere onto my points. And to clone stuff, or to copy stuff, we have a node called copy. And this is actually the MoGraph cloner in Houdini. And if you hover with your mouse over those two ports and hit the middle mouse button, you get some information what the node expects here. So first input is primitives to copy, and second one is template to copy to. So we want to copy the sphere onto these points. And if we set the display flag active here, we should see our spheres popping up here. So if I hit play, we see how they appear and disappear again. So very straightforward. Maybe we make them a little bit smaller for now. Maybe 0.1. Like this. Okay, so now we have our bubbles, and up here we have our main object, which should boil. And what we need to do now is to merge them together. And a very nice way in Houdini to merge or mesh stuff together are VDBs. So it's a special kind of volume which calculates very fast, and you have very nice tools to work with VDBs. And I'm pretty sure you'll find a lot of tutorials on Vimeo or YouTube where VDBs are explained a little bit more in depth, but I just show you what I did here with VDBs. So first of all, we need to convert our polygon object here into a volume. So for that we have VDB from polygons. And simply connect the sphere to the first input, set the display flag on this one. And now we see that it's not polygons anymore, now it's a volume, so voxels. You can imagine it as a the model is now made out of tiny Lego bricks. So it's if you have ever worked with Turbulence FD, for example, that's also a kind of volume where we use voxel to represent our object. And the good thing is, if you have volumes, you can merge them together pretty easily and mesh them in the end again, and you get a nice mesh flow and don't have problems like you have with bool operations, for example. Okay, up here in the VDB object we can define our voxel size. So the higher the size, the lower the resolution will be. So if I set it to 1, for example, it's pretty low res. I think in our case 0.1 is fine. We can adjust that later, of course. And to merge those two together, I need to convert my bubbles also into a VDB. So I will use it again, VDB from polygons. Merge it in here. And also increase the resolution. So 0.1 doesn't seem to be high enough for them, but we'll adjust that later. And to merge it together, there's an old code, VDB. If you type in VDB, you get all the nodes which are connected to VDBs, which is super cool. And in our case, we use VDB combine. Plug them in. And set the operation type from copy to SDF union. Then it puts both of them together, and now we can see that the resolution should be higher. The good thing now is that we can increase the resolution here on this node only, and it is set to resample B match to A. So the resolution from this one is adjusted according to this one in that node. So let's set it to 0.02 maybe, which is pretty high, and it looks weird. 0.02, maybe I'll set this also by hand. It seems to work better, so forget what I said here. It doesn't seem to work so good. So now we merged our stuff together, and just to take a look at it, how it will look like if you mesh that, we use a convert VDB, where we can convert our volumes again to polygons. So just click the convert VDB node and set it to convert to polygons, and then it's meshed, and you get a very nice quad mesh here, and you see that we have very nice transitions between our bubbles and the main surface. So for now it's a working setup, so if I hit play, you can see that it kind of works. So they pop up and they should disappear after a while. It's generated in every frame, and for that it's pretty fast, I would say. It's cool. But of course we don't want the bubbles to just appear in 1 second and just pop out of nowhere. So we want them to scale up and grow over time. So we can do that by simply generating an attribute. The cool thing in Houdini is that you can store attributes on points, and you can store as much attributes on the points as you want. And here in the copy node, this copy node uses the attributes of the points where you copy to. So these points, you can give the point an attribute, which is the scale of the point. You won't see that here in the viewport, but the point knows how big it is. And then the copy node reads that out and scales the spheres according to this attribute. So for this one, we will create an attribute bob down here. So an attribute bob is, or bobs in general, bob is a short version for Bex operators. And in there we can do some calculations. Actually, it's pretty similar to Expresso, just much faster. And you can do more stuff in there, but you will see that a lot of the nodes are very similar to Expresso if you're coming from C4D. So let's connect our pop object to the attribute bob, and we call this one create point scale, and connect that to the copy node. So make the display flag on the copy node that we can see the result here, and jump in there, and you will see something like this. Let me just make the space a little bit bigger here. So this is actually our inputs, so the data that comes into the attribute bob node, and this is our outputs, and you can generate more outputs if you want. And we can see some stuff like point, position, velocity, force, age, life. So this is a lot of attributes that the points can hold, and of course you can create more. And we want to use the age of the particle to scale over time. And if you want to see what kind of data your point has stored, you can unfold the geometry spreadsheet. I think by default this tab is somewhere up here. And on the geometry spreadsheet you get a table. And right now we see 3 points, and this is why we see three rows here. And we see it has a position, X, Y, Z, it has an age, ID, lifetime. So this actually here, the life shows us how old the particle will be in the end. And age shows us how old the particle is right now. And source primitive, all the stuff you can read out here. And we want to use the age to scale over time. So in Cinema 4D you would simply use a range mapper to do that and would range map the age onto a scale value. And luckily we have something similar here in Houdini, which is called fit range, I think. Fit range, right? And if you click that, you see that the settings are pretty similar to the range mapper in C4D. You have source min and source max, and destination min and destination max. I think in Cinema it's called lower input, upper input, and lower output, upper output, or something like that. And we want to use the age, which is here. So we connect the age to the value field. And now we can define how we want to map this. So the source min is the minimum age of a particle, and this is obviously 0, because if the particle is just born, the age is 0. And the source max should be the maximum lifetime of our particle. And if we scroll over here, we can see that our 3 particles have 3 different lifetimes. This is because when we created our particle system, let me just go back and dive into our POCnet again. Here on our particle source we specified that the life expectancy should be 1.5 seconds, but we have a variation in there of 0.8 seconds. So all of our particles have a different life expectancy. And of course we want to take care of that into our setup where we define the particle scale. So we won't type in 1.5 in here. We could do that if all the particles have the same lifetime, but we won't do that. We want to connect the source max to our life value here. So we take life, plug it into source max, and we will map the lifetime of our particles on a value between 0 and 1. So all the particles, no matter how long they live, over the lifetime they will have a scale value which grows from 0 to 1. That's pretty cool, because after that we can do stuff with this range also, and for example define a curve that it grows and shrinks down again or stuff like that. So now we want to store that value into an attribute called pscale. And as you can see, our output doesn't offer us this attribute, which is why we have to build it by ourselves. For that we have a node called bind export. So if you want to store an attribute which is not listed here, or a custom attribute that you want to use later, you use a bind export. If you want to read that out, so create an input, you only use a bind, not a bind export. So create that here and connect that to that input. And now we have to name our attribute. And our attribute will be called p-scale, point scale, and it will be a float value. If it's not a float, you can store all kind of stuff here, for example, vectors or colors. Yeah, just call it p-scale, and we're actually done over here. So if we go back, our copy can now read out that the points have a scale value, so it's called p-scale. You have to name it in the right way. If it's not called p-scale, you have to rename it, that the copy sub knows what you mean. And if we now hit play, we can see that it already works. So we have our spheres which are growing over time, and they have the size 1 when they die down and disappear. And if I click again here on our create p-scale attribute and we take a look at the geometry spreadsheet, we can scroll over here and you will see that now our points have the attribute p-scale that we can reuse. And you can, as I said, you can plug in as much as you want in here. Okay, but that's good. So this is actually the hardest part of the whole thing. We have growing spheres over time. You can adjust the initial scale of your sphere in here. So if you want them bigger, simply make them bigger. They will start at 0 and then grow to their final size. You could also build in some size variation in here and stuff like that, but I will leave it like that for now. Maybe let's do it like 1.5, seems to be a good size. And if we go down our tree again, we can convert them to VDBs, what we did, we merge them together, and then we can mesh it. And so this is part 1. So for now this is a solid object, so our bubbles are not hollow. So this is what we want to do now in the next step. So let's get rid of this convert VDB, that we have our volumes again. And this is the nice thing of a procedural workflow. We can reuse stuff that we created earlier and do calculations with it and combine it with other stuff. And what I want to do now is use my merged volume here, where we have both of our objects, then use the bubbles volumes, shrink them down a little bit and subtract them from the combined volume so that we make the bubbles hollow. So to do that, we use again some VDB tools. So there's one called VDB reshape, and we connect that to our bubbles. And if you take a look at it, we have some operations here. Right now it's set to dilate, so if I increase the value, you see that our bubbles are blown up. And there's another one called erode, which makes the opposite. So if you increase this value, the bubbles shrink down. And I will set that maybe to an offset of 2. So with the first flag here on the node, you can bypass the node. So you can deactivate it and see the difference. So that was before, and now we shrink it down to this size. And to subtract it from our combined volume, we use again a VDB combine. Plug them in, so the combined one we plug in the first, and our shrink bubbles we plug it in the second. Set the display flag on this one, and set the operation to STF difference. And now we can't see it right now, but maybe we can see it if I go close enough. It's hard to see. So the bubbles are hollow right now, and if we convert that back to polygons, so convert VDB, connect it, set the display flag, and convert it to polygons, we see the same result as before. But if we go close and the geometry is clipped by the camera, you can see that we have 2 walls in here. And actually if I go into the sphere, we can see that we have our inner bubbles sitting inside of the geometry and giving us this nice result. So if you would now just take this geometry and render it with a nice translucent shader, some subsurface scattering, you should see this effect pretty good, actually, like in the video that I recorded earlier. So here you can see that you have this double-walled bubble. To make the wall thinner, you just have to increase the resolution of your volumes, but for this example I just leave it like that. And now we can of course do more stuff with it. So for example, if you want this transition between the bubble and the surface to be smoother, we can smooth that out. And for that, let's see, we should take this combined volume and smooth that. So let's just take a VDB smooth, connect it, and if I set, just take a look at the geometry, if I set the display flag on that, you see that it gets smoother. It is possible that if you do that, let's see, not yet, sometimes you see some holes in there because through using the smooth node the geometry gets a little bit smaller and then sometimes you get intersections. If that happens, simply use another VDB reshape and dilate it a little bit before you smooth it so it gets bigger and then you can smooth it. But for this example, I think this looks pretty cool. In the smooth, of course, you can define the iterations, how much you want to smooth it, but I think the default value is nice here. And let's hit rewind, take a look at it again, and we see that the bubbles are growing and disappearing in the end, and it's already a pretty nice effect. Let me just put that one away. What we also want to do is to make some deformations on the object. So while it's boiling, that the surface is moving a little bit to all sides. And we can do that pretty easy using a noise. The thing is, up here we created our sphere and put some particles on there. And if I would now just use the sphere and deform that, the particles wouldn't follow the surface. They would stick to the surface. They're born somewhere in space, and then when the surface moves away, the particle would still be there. And we don't want to do that. But there's an easy fix for that. And let me just make some space here. By the way, if you select a node and hold down Control and then move the tree, all the nodes underneath it will also move. If you hold down Shift, all the nodes which are above this node will also move. This is super handy, so let's just move it out of the way. And let us merge the sphere geometry and our generated points together, then deform the two together and then split them again. So we use a merge and connect the sphere and the pop nut. And now we see both together. And we can see that the points coming from the pop nut, if you hold down middle click on the node, you see some information here. One says that there's one point group, so those points are stored into a group. Groups are similar to selection tags in Cinema 4D. So basically, when we merge them together, deform them, after that we still have a selection where all the points of the particles are stored, so we can split them into two objects again afterwards. So I hope that's clear, but you will see what I mean. So now we get a warning sign here because our particles have some attributes which our points on the sphere don't have, but that doesn't matter in that case. And to deform it, we have several options. I will use a point warp and use a noise to deform it. So let's call this one deform object. Connect our merge to the point warp. Set the visibility tag on that, visibility flag, and dive in here. I again need some space. Okay, and now I want to use a noise. For this example, we can simply use a turbulent noise, which looks like this. If we click on it, we set the signature to a 3D noise because we want some vectors that show in different directions, and as a noise type we use a zero-centered Perlin noise. And it works like this. Every point on our geometry checks its position and looks up in the turbulent noise what kind of value the turbulent noise has in that position, and then we use that position and add it onto the initial position of the point to move it somewhere in space. So we use the position, as I said, and plug that into position of the noise, that it knows which position to sample. And then I use an add, and add the noise value to the position of the point. and the result will be our new point position. And as soon as I connect that, you can see that the points are now deformed. So if you click on the noise, you can adjust the amplitude and all that stuff. We simply leave it as it is right now. And the only thing I want to do is this offset parameter. If I go in here, if you go onto a value and hit right mouse button again, you get this ladder, which is pretty cool. So if you go to 1 and go to left or right, you change the value in 1.0 steps. And here you can change it in 0.1 steps, and the other ones also to adjust it very, very good. And I actually want to use this value to move the noise in space that my object is moving. So let's do this. I don't want to do that in here. I want to do it one step back onto geometry level. So to expose those parameters to the geometry world, that we can adjust it from there, you simply go on offset, middle mouse button, and promote parameter. Then you get this little dot here. And if we go one level back and click on our pointer, we see this value up here now. So, and I simply wanted to change over time, so I type in a little expression, $F. I think there's in Houdini 15 it changed. You can now type in, let's try that, at time, I think. Then it's per second. No, it doesn't work. Maybe like this. Also doesn't work. Okay, if someone knows what I have to type in here, let me know. The old school way was to type in $F, which means frame. So it changes with every frame, and if you hit play now, you see that it's pretty fast. So we simply divide it by 50 maybe. That looks cool, maybe a little bit slower. Divide it by 80. I think that's good. Okay, the problem right now is that we need on the left side only our deformed sphere, and on the right side our deformed or moving points, so we have to split them again. But as I said earlier, the PopNet actually stores the points in a group, so we can use this group to separate them again. And to do so, we use a blast node. So with a blast node you can delete one group out of a combined geometry. So let's connect it, set the display flag on this one, and we want to click here, and here we see our group which exists. Simply click that, then you can see only the sphere without the points, and we copy this node that we have a second time, and check delete non-selected, so we simply invert it, and then we have only our points here. And now we can connect them again. So up here we used our points and created the p-scale. So we simply connect this to that one, and we connect the VDB to this one. So now we extended our setup. So in here we should have the volume of our deformed sphere, and in here we should have the points, and in the copy it should now also generate the points on our deformed sphere. By the way, if you want to see the wireframe of the underlying geometry which we use to generate our points, you can always click on this purple button here, which is the template flag. So then you can, basically the blue one defines the output of this node, but with this one you can see the wireframe of this node. This can help. So we can see that it works pretty good now. Remove that again, and if we go all the way down to our object, we have it over here. We can hit play, we see it deforms, and also the bubbles build up. And that's actually the setup. So from this point on you can extend it, you can do more stuff, build in more variation, more noises, more whatever. And always expose the parameters inside of those VOPs that you can adjust them from here. You can, of course, dive into the PopNet and adjust the amount of bubbles, the size, and all the stuff that you want. And use that in Houdini, or build a Houdini digital asset and use that in Cinema 4D. If you want to know how that works, maybe just watch my last video where I explained exactly that. So basically, that takes the setup from this step on and shows you all the steps which you have to do to use it in Cinema 4D. Of course, you can also create an alembic ROP alembic output. This is a node. If you connect that to the last one, you can simply write out an alembic file where you can store in all your animations. Yeah, and if you want to see a preview of your setup here in Houdini, like a viewport render, you can always click on that one, which is called Flipbook, and then a window will pop up over here and basically show you exactly your viewport and cache the simulation one time, that you can see it in real time. Okay guys, that's it. I hope you liked the tutorial. Let me know what you think and write your opinions in the comments below, and I'll see you in the next video. Bye bye.